Okay, so let's save this graph. 6.2 solving Quadratics by graphing and factoring, completing the square. Simplifying. So solve for f of x when the function f is quadratic by completing the square. That's this procedure. First we move c. Second we make a equal to 1 by factoring a. Complete the square by splitting b into half, adding and subtracting b squared. And fourth, write the square for x by applying inverse operations. Okay, first we have to have a problem, so let's write a quadratic in factored form. We could go a and then x minus root 1, x minus root 2. And that would give us this quadratic. We can change a. We can change the roots. So it's crossing one at, say, 3 and -5, -6. It means that your 0 is at -6 and the other 0 is at 3. See? This would be your minimum. Okay. And it would take this form. So let's pick a particular one, like 9 and actually I like to put my negatives first, plus 1 and x minus 9. And I want you to note that these zeros are obviously -1 and 9, because by the zero polar property solved by factoring, we would see that -1 plus 1 is 0, and times this would still be 0, and 9 minus 9 is 0. Regardless of what a is, a just stretches the function. But anything times 0 is 0, so these zeros remain what they are. By multiplying by name, you just switch, or the a, you just switch that out. So for now, let's put this at 2. And let's switch this to standard form, which would be 2x squared plus 9x plus x gives me -9x plus x minus 9. So you see that this function is indeed this. This is the first multiplication. Add these four terms together, we end up with 8x. Multiplying it by 2, 16, and 18. So this would be standard form. Our next job is to change this into a vertex form or transform form. So v of x equals, well, what does it equal? And I'd have to follow these steps. First, move c. So I would say 2x squared minus 16x in parentheses, like so. And I'm just going to move its bases and put the minus 18 over here. You see that this is still the same curve, still has the same zeros. I already know the answers. But the point of the exercise is to learn how to complete the square. So I've isolated the x's and put the constant over here because this is not a perfect square. This can be represented with a rectangle, not a square. So what I need to do is, in my next step, is step 2. uh, make a1 by factoring a. You could also divide. It's easy to see here because I multiplied everything by 2. But that's not always the case, so I will call this v2 and put out the 2 in the front. X squared minus 8x minus 18. So that's my second step. My third step, let me move my steps so I can see my steps. And see that. I'll verify that my steps are correct by checking the graph. So my third step equals twice. And now I'm going to write this as x squared. Split the x term, the linear term, and add 4 times 4, which is, or 4 squared. Since I added it, I now have to subtract it. But note that I have to multiply it by a. Okay, so this is my step 3. Complete the square. Complete the square by splitting b of x into 2 and adding half and subtracting half of b squared. Okay. So the square is complete. Okay. But note that I had to do 2 times this, and I had to subtract it because I just added it. So that's the 0 I want. The 0 I and you want. Yes. Anyway, come back here. I have to do 2 things now. Write the square and solve for x by applying inverse operations. Okay, so, or I could simply replace this with simplify. So am I supposed to simplify? Okay. I got the L. Okay. So let's do that. Step 4. So I've got my A, and now this is, I copy all this right here. And this, I need to figure out what this is. So I need to do this right here, and I see that's negative 50. So now I know it's negative 50. Yeah. And this is all of this. No, excuse me. This gone to here, and this goes away because it's basically this, right? Multiplied by something that's a perfect square. Or I can just say squared. Now you see that I still have the intercepts. For negative 50, you can read off the vertex form, the transform form. That means you moved 4 to the right and 50 down. This is the vertex form. I could also rename it a transform form, which call it t of x. Okay. Algebra 1 students would call it vertex form. We can also see that in standard form here, negative 18, you can see that that was going to be, when that's x is 0, you can also do it here. 2 times 1 times negative 9 is negative 18. See, so again, 2 times 1 times a negative 9. Anyway, and that completes the lesson on how to switch this. But next is, how do I find the solutions? Well, um, leave it there. We have to ask, when is this equal to 0? Okay, that's the question. And there are the answers. But we'd have to manipulate this. So we'd add the 50, or write this. This would equal to 50. Then I'd have to divide by 2, which is equal to 50 divided by 2, which is 25. Then I have to take the square root of x minus 4 squared, and that have to equal, equal the square root 25, which is x minus 4 equal to 5, x minus 4 equal to negative 5. So adding 4, x equals 4 plus 5, x equals 4 minus 5. And those are your solutions. Let's save that. And here they are. Okay, and those vertical lines appear because I'm showing all these steps. So every time you say a true statement, draws those lines, because that's the x that makes it true. Finally, here's a green line. I can switch it to green and 2. So that you see 2 green lines crossing the black. Right? Okay, saving that. Solving f of quadratic by completing the square, factoring, and graphing. Next video we'll connect this to the quadratic formula.